Okay, so, oh, sorry, where is my OneNote? Here we go. Okay, so in the next part, it says we need to find the measure of the acute angle. Now, when you think about any two lines that intersect, there will be an acute angle and then there will be an obtuse angle. So we're only interested in the acute angle. Now, between the lines L and K is theta, so we're going to call it theta. Show that the sine of theta is 4/5. Now, this may have thrown you straight away because the only formula in our log tables about angles between lines is this one. Now, even though this is tan and they've said sine in the question, you need to persevere and go, okay, well, maybe we can make a connection later, but it is absolutely this formula. So this is again on page 19. All of these circle ones are page 19. So, and I know this isn't a circle, but you know, they're all connected, the circle geometry and line geometry. Now, it's L and K, so we already have the slopes of L and K. So let's just write down our slopes again. The slopes were 2 and 2/11. So they were the two slopes. So we'll just call one of them M1 and one of them M2. So when I go to fill this in, I have 2 minus 2/11, 1 plus 2 times 2/11. Now, my calculator is basically going to do this job for me. So once I put it into my calculator, there's going to be, so you can try it there yourselves, and one answer is going to be 4/3, and the other answer is going to be minus 4/3. So in other words, one is the positive version and one is the negative. That's because of the plus minus. Now, we're going to ignore the negative, and the reason I'm doing that is because, again, we're interested in the acute angle. So if you think about your unit circle, all stupid teachers cry. To be an acute, it can only, if it's a triangle, it can only be in the first or second quadrant, because if you think about a triangle, it can't be a reflex angle, it can only be acute or obtuse. In the second quadrant, tan would be negative, so that's why we're not using that version. We're only interested in the first quadrant, as in we're only interested in the positive one. Now, how do we make the connection with sine? Well, the best thing to do is just draw a sketch. If this is theta, now teachers often annoy O/A, opposite over adjacent. Now, if I want to do sine of theta, summer's often hot. Sine of theta is going to be opposite 4 over the hypotenuse. Now, I don't have the hypotenuse, but I can easily get it using Pythagoras. X squared is equal to 4 squared plus 3 squared. X squared is equal to 16 plus 9. X squared is 25. X is the root of 25, so X is 5. So that ends up being 4/5, which is exactly what we needed. The next question was straightforward enough. A circle S has center 7 minus 8. Please always do a sketch, and it passes through 2 minus 2. Now, I mean, I have no idea where that is, but I'm just putting it, it's just a representation. Find the equation of S. Now, to get the equation of any line, I need my X, or any circle, sorry, I need this formula on page 19. Do I have my radius? Well, I don't, but I can get it by getting the distance between the points. Do I have my center, HK? I do actually, because I've been given the center. So I'm just going to label that HK. That, you know, the log tables reminds me to do that anyway. So this is what I have. Now minus k, so that's going to be plus 8. Just be careful with your signs. To be squared. Equals. Now, I don't have my radius, so I'm going to have to work that out. So I'm going to get the distance from the center to 2 minus 2. x1, y1, x2, y2. I put it into my distance formula, x2 minus x1 to be squared, plus y2 minus y1 plus to be squared. So that's going to be 25. That's going to be 36. So what's that? That's root of 61. So putting that in here, it's going to be the root of 61 to be squared. So of course, the final answer then is not going to have the square root. It's just going to be the 61 because when I square a square root. So I gave that 5 marks. And then just quickly have a look at this bit. Q is the point on circle S. that is closest to the x-axis. Find in surd form the coordinates of Q. Now, let's look at our diagram for a moment. When we imagine 7 minus 8, like if you think of your coordinate geometry diagram, 7 minus 8 is somewhere down here in the fourth quadrant. So the closest I can get to the x-axis, I would still have a 7, if that makes sense. So wherever this point is, it's going to be 7 something. Now, what is it going to be? Well, in a way, it's still going to be so it's going to be 7 over minus 8 down. So if I want to get as close as possible to the x-axis, I'm going to start from minus 8 and I'm going to add on my radius. Because if I start from the center and I add my radius, I'm going to get a point on the circle and one that is closest to the x-axis. And that was worth 5 marks.